Alright everyone, this is the third installment of my Introduction to R series. Up until now, all of our work has been done from the command line, but this time we're going to talk about writing scripts. A script is just a standalone file with some code in it that can be executed by the programming language's platform or the interpreter. So let's get started. As you can see, I fired up my trusty Cygwin terminal. Again, I'm in the Windows 7 platform. And what I'd like to do is create my script on the desktop. So I use path of working directory or PWD to see where I am, and I'm clearly not on the desktop, so I'm going to first CD into that directory, and here I am. Next, I want to create the file for the script, and since my script is going to graph some Fibonacci numbers, I'm just going to call it Fibonacci.r. Next, I'm going to use a text editor to open up that file. In this case, I'm using Vim. First, I like to add a brief description of the script at the top of the file. This is encapsulated in a block comment so R doesn't try to execute this description as viable code. Personally, I like to include information like the file name, date at which it was written, the author, in this case me, usage or how I implement the file, and a brief description. In this case, we're calculating some Fibonacci numbers and plotting them. After I've finished my header, it's time to start diving into some code. First, I want to define a function to generate the Fibonacci numbers. That way I could use it multiple times throughout the script without having to recycle the same code over and over, and I can even call it across other scripts. I like to add code comments periodically throughout the script. That way I could see at a glance what each block of functionality is doing without trying to parse the code. Next, I'm going to start my actual function definition. Since I want to generate Fibonacci numbers, I creatively name it Fibonacci. I tell R that this is a function by invoking the function keyword and telling it what arguments I want. In this case, I want a certain number n of Fibonacci numbers. The code body, or the guts of my function, starts after the first curly brace. Recall that a given Fibonacci number is simply the sum of the two that came before it, and we start with 1 and 1. Now, there's a million ways in R to get the job done, but I'm going to stick with the while loop here, even though the while loop is probably one of the most inefficient methods I could possibly choose. But it's easy to read and understand, which is important, especially as a beginner. I'm also only generating a few values here, so I'm really not going to notice any latency anyway. But if anybody has a snappy one-liner or otherwise creative way to do this, please feel free to leave it in the comments. Again, I start a while loop by calling the keyword while and then specifying a condition. The loop will run as long as this condition is true. The body of my while loop is where the magic happens. This is where I calculate the Fibonacci numbers. Again, a given Fibonacci number is just the sum of the two that came before it. Once I've calculated each Fibonacci number, I append it to a vector of Fibonacci numbers that I'm accumulating from the beginning in what I call the return value. Here I'm using the function rbind to append the new value to the old ones that I've already collected. Using the return keyword, I specify that the output of my function is the return value, or the series of Fibonacci numbers I've just generated in the while loop. Now we want to implement the function to pump out some Fibonacci numbers. The first thing I'm going to do is actually add a parameter to run in effectively a debug mode. What I mean by this is I'm going to have R echo or print every line that it tries to execute. That way, if there's a problem, I know exactly where it failed. I do this by calling options and setting echo to true. Next, I want to take in a command line argument from the user. That way, the user can specify how many Fibonacci numbers they want to generate and to graph. I'm going to use the command args function to grab that input from the user, and I'm going to store it in a variable called args. I'm assuming that the very first argument is going to be the number of Fibonacci numbers desired. That's going to be the very first element in my args variable. Now, when you take in arguments from R, it doesn't necessarily understand what type you want. In this case, we need an integer. So I'm going to use the asInteger function to make sure R understands that we need to convert that input string into an integer. Now I have all the information I need to generate my Fibonacci numbers. I'm simply going to call the function I defined above using that input variable I took from the user as an argument. Again, that value corresponds to how many Fibonacci numbers I want. I'm going to store the values that the Fibonacci function returns to me into a variable called ret. Next, I want to print out those values just as a sanity check to make sure my algorithm is working properly. In the final step of this script, I'm going to graph the values that the Fibonacci function generated. First, I want to generate an index of my Fibonacci numbers. This will act as the independent variable in my graph. I can use the colon operator to generate a vector of integers spanning from 1 to however many Fibonacci numbers I have. I can use the nrow function to determine what that number is. Next, I'm going to begin the graph itself. I call the PDF function to tell R that I want a PDF for the output file type. Next, I specify the name of the PDF, or Fibonacci.pdf, because again, I'm not very creative. The function that generates the graph is intuitively called plot. In the first argument of my plot function, I'm going to specify what I want R to plot. There's a couple equivalent ways I could do this. Here I'm choosing to specify what's called a formula. Basically, a formula is like a little equation. I specify the dependent variable followed by a tilde followed by the independent variable. Now there's lots of cool stuff that we can do with formulas in R, but right now we're just going to stick to graphing it. Now we're going to add some options to the plot function to customize our graph. First, I specify the type of graph that I want. There's a lot of different things I can plot, like histograms or dots or lines, but this time I'm going to specify a B for both. That means I'm going to specify both a line connecting the points and a little dot for each point itself. The main argument lets me specify a title for my graph. The xlab and ylab arguments let me specify a label for my x and y axes respectively. There's tons of other additional options I could use to further customize the graph, but I think this is good enough. Dev.off tells R to go ahead and render the graph. At this point, we're done with all the code that we need to graph these values. Let's give the code a quick run through and see if there's any glaring errors that jump out at us. So far so good. No glaring errors are jumping out at me. Let's save our work and exit the text editor back to the command line. Finally, we'll invoke rscript.exe to execute the script and graph the values. Don't forget that our script requires a command line argument, or how many Fibonacci numbers we want to graph. Let's have our script graph the first 10 values. And it looks like we have an error. So R is having trouble finding the function option. That's because there is no function option. It's actually options plural. Luckily, that's a pretty simple fix. All we have to do is open up the file again and make the appropriate change. There we go. Let's save our work, exit out, and try again. Good news, no more errors. In fact, we see all the Fibonacci numbers that we asked R to print out for us, as well as the debug data that we asked for in the options. Also notice there's a little file generated at the lower left-hand corner of the command prompt. This is the graph. If we click on it, we should see our result. And there it is. That's about all for this tutorial. Feel free to mess around with some of the other options in R and customize the graph and functionality in whatever way you see fit. As usual, thanks for tuning in. If you haven't already, please don't forget to like and subscribe.